So, how is everyone today? I hope you're doing fantastic. Now, speaking for myself, I don't know if it's my allergies or whatever it is, but it's a rainy, dreary morning out here, and my eyes are tearing and I am yawning like crazy. So, you may hear me do that multiple times during this and the next, during this and the next video. Hopefully, I didn't make you yawn where you're sitting right now. So let's get rocking on today's lesson. We got our pregame stretch up first, so let's do that. You know, you can do stop and start. I'm going to scroll through this all in an effort to condense the video as best we can. So stop and start now. I'll scroll up. There's the next set of problems. Little stop and start there. And a graph. All right, so once you're done with all of that, you could proceed in the video to check out this. Here are the correct solutions. Now, it would be really nice to have a give and take. Excuse me. One of the few disadvantages of watching this from home on the video is that we really can't have much of a give and take. If you need help, you can speak to a friend, email me, etc. And don't forget, if you ever want to use office hours, very important, you have to email me in advance. That way I can send you an invite. Okay. Next set of answers. By the way, I am yawning here, but that's not me snoring. That would be my dog Ziva. Okay. And there's the graph. They do not meet at a perfect point. Sorry about that. A little poor planning on my part. Okay, so now we get into the PowerPoint lesson for today. Okay. Let me get rid of that. All right. Well, I hope my screen recording is doing the entire screen. I don't remember whether it said that or not, but we'll find out. You know, sometimes I see that the whole screen shows, and sometimes I see that it doesn't show. So when these videos get posted, there's really no rhyme or reason to it. I'm not sure. The video that I'm giving you on my screen, it's a full screen. And usually I ask at the start of class, and you as a class, you'll say, yes, it's a full screen. And then every once in a while, it doesn't come that way, and it appears to you like what we would call the presenter mode or the presenter view. And that's bad because then you have to look at a really small slide. And I guess you can blow it up on your screen, but it still lacks the clarity that we're looking for. So hopefully this is a full size slide that you see, okay? And from my perspective, I'm hoping that it's recording the entire screen as this is going on. Okay. So we're going to continue our work with polynomials, and this is lesson 10, which if you were in class the other day, you actually saw these examples. The other day in class, I did lesson 10, which involved basically a rehashing of lesson 9 plus some new work at the end. So what I'm going to do is make a couple of separate videos here that rearranges that and makes up for it. Okay? So, the homework review. Oh, I didn't put up the homeworks, but let me put up Safari. Oh, God. I'm sorry, I'm going to skip the homework answers because, like an idiot, I closed out of Safari before, and I did not want to do that. So, you do get to see the homework answers on the page. They are visible to you, so we'll be okay either way. Okay, we do the homework review, the pregame stretch. We went over the pregame stretch. The recent work recap we're going to do right now. So if you were sat in class the other day and did this, then what you're going to want to do is, let's say you were in class on Monday, and now you're missing Wednesday's class and you're watching this video. Go back and watch Monday's video, because Monday's video will have new questions on it. The first video from Monday, let it replace this video. And then after that, the second video for today, you should also watch. So here we go. First question. Go ahead. You know the drill with stop and start. Okay. So distributing the 4 and distributing the -3, I get a same side, same operation situation, which gives me 3n minus 49 equals 3n plus 3. Subtracting the 3n, very strange here. I get -49 equals, it should say 3, but it doesn't matter if it says 2. And at that point in time, you say to yourself, whoa, we got a problem. -49 never equals 3. And if it's never equal, it's never a solution. So there is no solution to this question. If it came out to say -49 equals -49, or 2 equals 2, or 3 equals 3, then everything is a solution. So in these odd cases that the variables wipe each other out, either there are no answers or everything is an answer. There will never be one answer. Okay, let's do these two inequalities. Graph them, bracket notation at the end. Go ahead. Okay, I assume you did stop and start. So I subtract 20, -3n is less than 9, divide by -3. Remember, if you multiply or divide by a negative, you have to negate, that is to say switch the sign. So not only on the 9 becomes -3, but the less than becomes greater than. So there's my graph, okay? For the next one, we have distributing the -5, combine like terms, -17x plus 82 is less than or equal to 7x plus 10. Adding the 17x, and then we get 82 is less than or equal to 24x plus 10, subtracting the 10. 72 is less than or equal to 24x, dividing by the 24. And I get 3 is less than or equal to x. Now that's awkward, because if you notice from number 1, we should be very used to having this variable on the left, and it just doesn't sit correctly when it's on the right. That's true with equations, but also with inequalities, and it's more disconcerting with an inequality, because in an inequality, as long as the letter's on the left, you draw the direction of the arrow, the line, the same direction as the inequality. So in this case, we want to rewrite 3 is less than or equal to x is greater than or equal to 3. It's the same statement, isn't it? 3 is smaller than x is bigger than 3, same statement. So when I rewrite it, now the x is on the left. Just remember, for practical purposes, if you're looking for a little mnemonic device here, if it points to the 3 here, when you switch it around, it's got to point to the 3. So because it's or equal to, I make it a solid line. As far as bracket notation goes, for the first one, you're not allowed to equal the -3, so it's a parenthesis. Goes on to infinity. Infinity is always a parenthesis. And I don't particularly care for this, only because it reminds me of coordinate notation, but I have to get used to it because it is something that we should recognize. And in the second one, you are allowed to equal the 3, so we use a bracket or a staple. Now, taking inequalities to the next level, it's really a matter of understanding what is and is not part of the solution. So try this one. Go ahead. Okay. So now we're going to combine like terms. That gives us the -8x. We're going to subtract the 7. -8x is less than 16, dividing by -8. That gives me x is greater than -2. And now we have to consider our answer. Is -2 an answer? No, it's not, because x has to be greater than -2. This specifically wants the smallest integer. Now, integers are whole numbers like 3, 4, 5, positive and negative, and 0. So what is the smallest integer that makes that true? Well, it's -1, because -1 is greater than -2, and it's the smallest integer that's greater than -2. And then you could always substitute it in and check, plugging in a -1, you would get 3 plus 7 is 10, plus 5 is 15, and 15 is less than 23. If I tried to plug in a -3, say, that would give me 9 and 7 is 16, plus 15 is 31. It would not be true. Okay, so the smallest integer is -1. Okay, let's see you try this guy right here. Go ahead. Remember, do stop and start. Okay, so what we have here is 2 bags of popcorn and 3 drinks. That totals $13. And then 4 bags of popcorn and 2 drinks. That totals $20. Now, I'm going to do things a little differently here than I have in the past. In most problems, I've been eliminating these D's in the middle, okay? But this time I noticed something. I noticed these P's are really easy to get rid of. Now, I want to make this perfectly clear. If you've grown comfortable with our system of basically saying, hey, look, there's a 3 here, I'm going to multiply the bottom by 3, and a 2 here, I'm going to multiply the top by 2. Because the signs are the same, both positive, I'm going to make one of those 3's or 2's negative. Go for it, if you never want to know more. But if you want to take it to the next level, you could look here and say, hey, look, 4's and 2's, 2's and 4's. If I just double this 2p, I get 4p, and that allows me to work. So what I'm going to do is multiply the top one by -2. Leave the bottom one intact. When I do that, the top one is -4p minus 6d is -26. 4p plus 2d is 20. -4d and 2d, -26 and 20, comes up to be -4d is -6, dividing by -4, and the cost of a drink is, drum roll please, $1.50. Now we finish it off just the same as before. Rewrite either equation. I chose the top one. Plug in the $1.50 for the drink. Subtract $4.50 from both sides. 2 pretzels is $8.50. That means every pretzel is 4 1/4. So those are the prices to deal with. Okay, now let's go over to solving a system algebraically. I'm going to pause my thinking for a minute, and don't do stop and start right away. I'm going to pause my thinking. Look at how you might do this, and in about 15 seconds, I'm going to talk again. Okay, so here's the thing. You realize that this is a substitution because the equals are not aligned. Now, in every other substitution that we've done, it's always said x equals or y equals. And now it says 4x equals. And that's disconcerting, and it should cause you discomfort because there is no 4x to substitute for. And when you encounter a problem like this, there is an alternative way to do such a problem. And I think in the previous slideshow we did this. You can subtract 3y's from both sides. I'll show you what I mean. If I subtract the 3y's from both sides, I get 4x minus 3y is 5. Why do that? Because now they line up and you can do the elimination as before. Now you can do stop and start and fill in the rest of the problem. Okay, so I'm going to work on these y's in the middle because I have opposite signs. So I put a 7 up top. You actually put a 3 in the bottom. That's right, not a 5, I'm sorry. This is wrong here. It shouldn't say 4x minus 5y. I got misconstrued over there. It should be 4x minus 3y, which I did continue over here. This is all because I copy it from previous days, and sometimes I forget to change one of the numbers. So if I distribute the 7, I get 28x minus 21y equals 35. If I distribute the 3, I get 18x plus 21y equals 57. I love it. I'm loving it. Ding, ding, ding. Negative 21, positive 21, they wipe each other out. 46x is 92. Dividing by 40x, I get x equals 2. Okay, let's go back and get y. 6x plus 7y is 19. I plug in the 2. 12, subtract the 12, 7y is 7, y equals 1. Okay, so there's my correct answer. One last question on this particular video. Or one last set of questions. Go ahead. Just in case you're seeing this on a small screen, which I really hope you're not, let me just tell you what they say. For letter B, it says in parentheses 1/3 x, and that's to the third power. 1/3 x to the third power. Letter S, in parentheses negative 2/3, and that's to the negative 2 power. Letter M, in parentheses, negative 2x to the third y over x to the negative 3 y to the sixth, all in parentheses to the third. Letter P, 3x squared y cubed, and then times negative 2xy squared. Then, for letter L, in parentheses, 4x to the fourth y squared, and then outside squared. And then letter A, 2xy squared, and then in parentheses, negative 4x squared y to the negative 3, parentheses squared. And then letter L, 3x squared, in parentheses to the third, over 3x to the seventh. So if you were unable to read them, you can copy down what I just said. If you missed it, you can play it back. Let's do all of those questions. There's a total of 7 there. Go ahead. Okay. So for the first one, I get either 1/27 x to the third or x to the third over 27. It's the same thing either way. For letter S, now, back when I taught in public school years ago, I would teach anything from 7th through 12th grade. And when you get this negative exponent up here, if I was teaching a younger kid, you teach younger students differently than you teach older students. So I would teach them, I'd say, sometimes it's best learned the way that we're in the military. So we go into the Marine Corps. And in the Marine Corps, that sergeant, he sits there and he screams at you. And he would look at you and he would say, a negative exponent! And the whole class would yell back, reciprocal, sir. So, a negative exponent, reciprocal, sir. So what that negative exponent at the 2 does is it flips the 3 over negative 2. And then makes it to the positive squared. So the negative flips it. Then we don't have the negative anymore because we used it to flip it. And then we square things. So 3 squared is 9 and negative 2 squared. Make sure you put that in parentheses is positive 4. If you don't put the negative in parentheses in a calculator, it will not give you the answer that you're looking for if it's a positive exponent. Okay, next one up. Starting from the left, the first thing I did was cube everything, okay? So that gave me negative 8x to the 9th y to the 3rd, right? Because there's really a little 1 here on the y, and 1 times 3 is 3. Over x to the negative 9 y to the 12. Then I subtracted exponents. 9 minus negative 9 is 18, and 3 minus 12 is negative 9. So that would be if I just wanted to write it with exponents. But sometimes they say using only positive exponents, and that being the case, you should recognize that y to the negative 9, a negative exponent, becomes y to the 9th in the denominator. Okay? All right. That's that negative exponent thing again, right? The reciprocal. So negative exponent takes the y to the 9th that was in the top, but because it's negative 9, it puts the y to the 9th in the bottom. Okay, next one. Multiply coefficients, add exponents. That would be negative 6, y to the 3rd. Remember, there's a 1 on this x. And then, x to the 3rd. Sorry about that. X to the 3rd, and then y to the 5th. My brain got a little ahead of me. Now, when we raise a power to a power, we multiply the exponents, but we do the coefficient to that power. So 4 squared is 16, x to the 8th, y to the 4th. For letter A, order of operations, I have to do exponents first. So first I have to take care of this parenthesis on the right. That gives me 2xy squared times 16, right? Because I'm going to square that negative 4. Make sure it's in parentheses. X to the 4th, y to the negative 6. Then I'm going to multiply the monomial on the left, the monomial on the right, which is multiply coefficients, add exponents. So that's 32, x to the 5th, y to the... And I don't believe that should say 8. I must have misread that. It should be y to the negative 4. So that should say 32x to the 5th, y to the negative 4. Just to be clear, 32x to the 5th, again, y to the negative 4, right? Because 2 plus negative 6 is negative 4. For some reason, I must not have seen that negative there and thought it was just a regular 6. Letter L, I'm going to do the exponentiation in the numerator first, then worry about subtracting exponents. So doing the numerator, I remember when I did this one, I'm not copying it out here. I said, you know what, let me make a mistake and see if the students can find my mistake. Go ahead, try to find my mistake. Yep. The mistake is that the 3 here is being cubed. So 3 cubed is 27, not 9. So this should read 27x to the 6th over 3x to the 7th, which would be 9 over x, or 9x to the negative 1. Okay, first video is now done. We'll get on to the second video, which introduces recent and new material.